Question 22. In this question, use a ruler and a pair of compasses only. The following figure is drawn to scale. It shows sides AB and AD of a trapezium ABCD, in which AB and DC are parallel. Angle DAB is equals to 40. It is there. And vertex C is not shown. So there we have the figure. Let's go to the first question. Part A. On the figure, construct Roman 1, the locus P of points equidistant from sides AB and AD. Locus P of point equidistant from side AB and AD. Which type locus is that? That is a locus that is equidistant from two given sides. The sides are AB and AD, and that is what we call the angle bisector loci. So to get locus P, we simply bisect the angle between sides AB and AD. So know how to bisect an angle. So simply stand here. A pair of compass, then mark an arc there and another arc there, then stand on this arc, then mark an arc there with the same radius without changing it, stand on this point, then cut that arc. So from there, join A to the point of intersection of the two arcs. Like that. So this is now the locus P. So that is the locus P. So we're done with that part. So we go to the second part. The locus Q of points equidistant from points A and B. So again, we need to know which type of a locus is this. This is a locus that is equidistant from two fixed points. Locus of points equidistant from two fixed points. The two fixed points are A and B. So we have A and B here. So how do we construct that locus? By simply bisecting the line that is joining the 2 points. This line AB. So when you bisect line AB, that perpendicular bisector will be the locus Q. So we bisect that. This is how we do it. Stand at A. You're bisecting or drawing a perpendicular bisector of AB. So stand there, open it more than half of that line, and then an arc there, another arc below, then the same radius without changing it. Stand at B, then cut the arcs, then join points of intersection of the two arcs. That. And that is the locus Q. So here we have the locus Q and the locus P is here. The next part, part 3, the locus R of points such that for ARB is equal to 70 degrees. So that is what we call the constant angle loci. And to explain that, let me use an illustration here. That is, those are points AB. You need to construct the locus R such that angle ARB is equals to 70 degrees. How do you get that? By simply making an arc like that, and all points on this arc, these will be locus R. How do you ensure that any angle made on this arc from point A, this arc, to B will be 70 degrees? You need to have a center. You need to construct the center there. And if the angle made by chord AB on this circumference here, for it to be 70 degrees, you need this one to be 140. Why? You're using the property, the angle subtended at the center by a chord. So the chord here is AB. So any angle subtended at the center by this chord here, the angle will be formed, the angle formed at the circumference here should be half of that angle. Or in other words, the angle formed at the center here by this chord should be twice the angle subtended the circumference. This is what I mean. Any angle that I will make this will be 70. Any angle that I can make this angle should be 70. So all these, any angle that you're going to make from A to the circumference to B, that angle is subtended at the center here by this chord AB. That is a property that you use to get this loci. It is called the constant angle loci. The angle subtended at the center by chord AB will be twice the angle subtended at the circumference by the same chord. So this is the property. So we need to have 140 at the center. So this one will be 20 degrees because this will be an equilateral triangle, an isosceles. This will be an isosceles triangle. So this will be 20 degrees, 20, 20, and so on. I already have this 20 degrees is given because you have bisected. So we need to have something like this. So from the diagram, we go to the diagram here. We already have this angle because we bisected. We have this one as 20. And having these perpendicular bisector, look at where these are bisector. The angle bisector meets with the perpendicular bisector loci. These will be the center. So these here, this point will be the center. This is what you're going to use. Because even if you construct, you take this distance here from A to the center there, then you transfer this on there, you notice it is touching at B. You can see that. So even if you join these, so when you join that, you will have this one as 20 degrees and this one will be 140 degrees. So the center has just come automatically. It is located at the point of intersection of these angle bisector loci and the perpendicular bisector of AB. That is the center. So with that center, this center here, with that center, simply open it till you reach this is a point A. And then you draw an arc. So draw an arc. So draw an arc like that. And these now, these will be locus R. So any angle that you're going to form from point A to any point of this circumference here, from A to any point of this circumference to B, will be 70 degrees. So that is the locus R. You're done with that. The next one is part B. Go to part B. Vertex C is such that angle ACB is equal to 70 degrees. Locate vertex C and hence complete the trapezium ABCD. So remember, we have the trapezium from the first part, and in this trapezium, already given that trapezium has two sides that are parallel to each other. AB and DC should be parallel. So when you look at whatever we have here, AB and DC, so C should be somewhere here. This one should be parallel. This one should be parallel to another line that is here. But how do we locate that point? If we have a line that is parallel, DC here and here, then this line AD will act like a transversal. It will act like a transversal, and I'm going to explain that one further here. So we have A, B, then this is where we have point D. So that line that you're required to draw, supposed to draw it somewhere there, and this one, let's say C is somewhere there. It's a sketch to help us understand. So this one, this line is parallel to this. So because these are two lines that are parallel and this angle is 40 degrees, then to obtain where we shall have C, we need to know how we're going to draw this straight line. And we're going to do that by copying this angle. If we copy this angle is equivalent to this angle. Angles on a transversal. This angle corresponds to this angle. So on this diagram, we simply need to copy this angle 40 degrees, then need to extend line. Need to extend that line. Need to extend it, line AD, like that. And then we copy this angle DAB. We copy that angle. This is just one of the ways to draw that line. DAB, which is 40, we copy it at D. So this is how we copy it. So I will stand at A, and then I will draw. Simply draw an arc. We draw that arc like that. So standing at D, I will draw same arc with the same radius without changing it, with the same radius. Just check what I'm doing. So standing at A, mark an arc there, then at D, you're copying that angle at D like that. Then you need to copy this one. Copy now this angle here. Copy it like this, like that. So let me show you properly. So copy it like that, or maybe you can place it like this. So copy that angle like that, then stand at this point and cut that arc like that. So I've copied this angle like that. That is the size. Then transfer this point where you made an arc and cut that arc. Look at the point of intersection now of those two arcs. Now you need to join these. Need to draw a line that is connecting. Look at the D and the point of intersection. D and the point of intersection of those arcs, like that. So draw a line that is passing through D. I think I need to draw that one properly. So let me draw the line properly. is supposed to pass through D, the point of intersection of those arcs, like that. So the line is passing through here. So this is point D, the point of intersection of arcs. So this angle here is 40 degrees. And this angle is 40 degrees. So this line is parallel to this line. These are angles. This is the angle that has helped us to do that. So now you need to locate C. And C is located on this arc. This point. Look at this point of intersection of locus of R and this line that you've drawn here. Look at this. Just look at it. This point here. This will be C. So C will be located here. So just join that point using a straight line like that. So point C is here, vertex C is here, the point of intersection of locus of R, this line. So we have located that. So now we have the complete trapezium A, B, C, and D. The next question is calculate the area of trapezium ABCD. Now we need to get the area of this trapezium ABCD. How do you get the area of a trapezium? Area is given by half multiplied by the sum of the two parallel sides times the height. We have these two sides that are parallel, DC and AB. Those are the sides. So we can call this side A and this one side B. Then we need to get the height. Now we don't have the height. The height will be given from this vertex here, D, perpendicular line from D to AB. So to get the height, let us draw or drop a perpendicular line from D. Drop perpendicular bisector line from D to AB. So to do that, so stand at D, then let me mark a big arc here. So mark an arc there and mark another arc there. So standing at D, mark an arc there on that line AB. Then stand, you have to extend these. Stand at that point that you've marked there. So any radius now, you can use any radius. Then mark an arc there. Then on the other arc here, then cut that arc. Let me join. So from point D to this point here, from D so this is perpendicular. So that is how we drop a perpendicular from D to AB. So we've just stood here, made this arc here and this arc, then stand on this point of this arc here. We've made this arc, then stand on this point here, that arc. So draw a line, straight line from D to the point of intersection of these arcs. So now this is the perpendicular height. So you need to measure that, so that when you're getting the area, we shall have half. So we need to measure line AB. We need also to measure DC. Then we need to get the height. So let's start with AB. Measure AB. So AB is That is 8.7. AB is 8.7. Gonna confirm these again. That is 8.7. Then DC. DC is 3.123. That is 3.1 to 3.2. Consider is 3.2. And height, the perpendicular height, is 4.2. 4.2. Now with these now you can get the answer. So area is equals to half multiplied by the sum of the two sides. AB was 8.7 plus the other side DC 3.2, then times the height, which is 4.2. So these will give half multiplied by 8.7 plus 3.2, that gives 11.9, then times 4.2. And when you work out this everything, just take 11.9 times 4.2, then we divide by 2. This will give 24.99. 24.99 centimeters squared. So that is how you're supposed to solve that question.